What is an antenna? Explain its important functions. We are all aware and are in regular touch of modern modes of communication such as televisions, radios, mobile phones and others. Mobile phones enable us to hear the voice of the person far away from us. With the help of radio, we listen to songs. While with televisions, we also experience the motion pictures. Have you ever wondered how these devices receive information? This transmission and reception of information in form of electromagnetic waves is carried out by an antenna. Thus, antenna is defined as a conductor or a group of conductors used either for radiating electromagnetic energy into space or for collecting it from space. Now let us understand how an antenna works. The information in form of electromagnetic energy to be transmitted is first fed into transmitting antenna. The information transmitted travels in space. And finally, the receiver antenna receives the signal. Hence, antenna acts as the means of linking the electromagnetic waves from transmitter to receiver. The major function of an antenna is that it radiates energy in a desired direction. Also, antenna acts as a transducer, that is, it converts high-frequency current into electromagnetic waves at transmitter end. Related term is. What do you mean by antenna parameters? Let us take an example of a class. Teacher selects only 8 students for a singing competition out of 50 students on the basis of pitch, volume, confidence, field of interest. Hence, here pitch, volume, confidence, and field of interest are the parameters on the basis of which students are being selected in a choir group. A limit or boundary which defines the scope of a particular process or activity is known as parameter. Similarly, an antenna for radio station is selected on the basis of various factors known as antenna parameter. And these can be gain, beam width, efficiency, etc. Thus, antenna parameters are the factors that select the antenna for specific purpose or application. Now, factors contributing to antenna parameters. First is radiation pattern. It is a 3-dimensional graph to show variation of electromagnetic field. This variation helps us in selecting suitable antenna. Gain helps to select an antenna by comparing the power radiated by it with the isotropic antenna. Beam width, as it tells about the area where antenna has maximum radiation. Continuing further about antenna parameters, directivity is defined as ratio of maximum radiation to average radiation of test antenna. The diagram for directivity of typical antennas are. Effective height. It indicates how effectively an antenna radiates or receives an electromagnetic wave. Effective aperture. Area of the antenna from where the radiation takes place. Here the rectangular area at the front is effective aperture. Related term is. What is radiation intensity and beam efficiency? All of us have seen a torchlight. Intensity of radiated light is more near a bulb than at a distance. Similarly, the radiated power and intensity of antenna is different at different places. In general, we define efficiency than, for example, if you and your friend is blowing balloons, and if you blow more balloons in same time, then we say you are more efficient. Similarly, signal transmitted and received by antenna says how efficient antenna is. Thus, radiation intensity is defined as radiated power per solid angle. The beam efficiency of an antenna is a parameter used to judge the quality of transmitting and receiving antennas. Now, radiation intensity helps in defining antenna parameters like gain, directivity and power gain. Radiation intensity illustration is shown in a figure. Radiation intensity depends upon angles theta and theta dash. The total power radiated from a radiator is calculated by radiation intensity produced by an isotropic radiator is given by. Also, the beam efficiency can be defined in following two ways. In terms of power, the beam efficiency is defined as the ratio of power transmitted within cone angle to the power transmitted by antenna. In terms of beam area, beam efficiency is defined as the main beam area ohm m to the total area ohm a, where total beam area consists of the main area and the minor lobe area. Related term is